So in section 4, we get a whole new batch of identities, and they're called the sum and difference identities. What that refers to is, if you look here at the first identity, you have cosine of the sum of two things, right? And if you look to the right of that, you have cosine of the difference of two things. So it's really important that here you have cosine of the sum of two different angles, or the difference of two different angles. Now, there is some new notation here. These are Greek letters, the first two Greek letters, and it's alpha and beta. And that should be familiar to you, right? Because it's the same in Hebrew, right? And that's where the word alphabet comes from. It's because it's the ABCs, right? So this is alpha and beta. The way they are written in print, that's what it looks like. In writing, alpha is like a little fish. And then B, so watch how, or beta, watch how we do the beta. It starts, bottom up. So it's like this. Okay, so it's like a curly B. You just start it from the bottom. Okay, so the book writes these identities in this way. And again, these are ones that you have to have memorized, but let me make them a little bit simpler for you. All right, so I'm going to sort of rewrite these. I'm going to write the one for sine first. Sine of alpha plus beta. Again, I'm adding one angle to another angle. And if you see, this is sine alpha cosine beta plus cosine sine. Cosine alpha sine beta. All right, let's just take a look here for a minute. You've got the trig function, sine and then cosine and then cosine and then sine. Now, look at the order of the angles. It's alpha and beta in that order, and then here it's alpha and beta, and here it's alpha and beta. So do you see how the order stays constant and consistent the whole time? So that's one thing. Now, look at that, and now compare it with the difference, sine of alpha minus beta. So if you compare, it's sine, cosine, cosine, sine again, but the only difference is when initially you have a minus, inside the identity, you also have a minus. So what we can do is, up on top where I wrote it in purple, you know how we always write x equals plus or minus 3 to condense? We can write formulas or identities in the same way. So we say, okay, if this was a minus here, then it would be a minus there. And that's a very common thing to do. So you take the top with the top and the bottom with the bottom. Okay, let's do the one for cosine. Cosine alpha plus beta is cosine minus sine of the first, sine of the second. Again, look at the order of the angles. Alpha, beta, that stayed constant. So one thing that is different with the cosine is you have a different configuration of the sines and cosines, but also plus and minus will alternate. Okay? And so if there is a minus here, there will be a plus there. Okay, so now, how to remember this? Well, guess what? There's a song. Here's how the song goes. This is how we write it in this way first, right? Sine and then cosine. So the way the song goes is sine, cosine, cosine, sine, cosine, cosine, sine, sine. Right, it's like Pop was the weasel. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. And if you remember it that way, then, right, it's very catchy. Like you'll be doing it like when you're having breakfast, when you're brushing your teeth.
When you're on the beach wondering, like,
right?
Huh? When you're on the beach.
Yeah, this is totally what so when you see sine, then you know it's sine, cosine, cosine, sine, and then when it's the cosine, it's the other one. Cosine, cosine, sine, sine. All right? Okay. The only thing you have to remember then is if it's sine, then the plus will remain a plus and so on. If it's a cosine, plus and minus will alternate. Okay, tangent, you're on your own for tangent, but there is a cute little pattern. So if you have tangent of alpha plus beta, look at what happens. You have each angle get its own tangent, tangent of alpha plus beta, and then in the bottom you sort of have this, right? This you just have to memorize. As far as plus or minus, if it's plus here, that plus is maintained once, and then it switches. So if it's a minus, that minus is maintained, and then it switches. So again, these you have to have memorized, and more than that, it's not just knowing it, it's knowing when to use it, right? And you're seeing that more and more. Okay, so when do we use this? All right, so we know how to find trig, we know how to evaluate trig functions for specific special angles, right? 30, 45, 60, the 90s, right? And then, the ones that correspond to them. So 135, 225, 120, those we know. But what if it's an angle that is not one of the special angles, like 75, right? Sine of 75. Sometimes there is just no way to do it manually. You just have to go to the calculator. But there may be other ways that we can use identities to evaluate something like sine of 75. The trick is to write sine of 75 as either a sum or a difference of two special angles. So 75 can be rewritten as 30 and 45, right? So I can rewrite this as 30 plus 45. So do you see how, and now it's sine of the sum of two different angles. So now it's the first one. So it's sine of alpha plus beta. So it's sine, cosine, cosine, sine, and that's how we do it.
Cosine, cosine.
So the 30 and the 45 has to stay in the same order. Once you write it in that order, you commit to that order. Now, if from the beginning you did 45 plus 30, then you commit to that order, okay? All right, so this is going to look like sine of the first, cosine of the second. And remember, sine keeps the plus. So sine, cosine, cosine, sine. Cosine of the first, sine of the second. Okay? So look, it's sine, cosine, cosine, sine, and then 30, 45 everywhere. All right, now, well, we totally know what sine of 30 is and what cosine of 45 is. Sine of 30 is 1/2. Cosine of 35 is 1 over root 2. Plus, if sine of 30 was 1/2, cosine of 30 must be the other one, root 3 over 2, times 1 over root 2. Question? Because I know that the identity says for sine of a plus b, if it's a plus here, it's a plus there. Okay? All right, so now I have 1 over 2 root 2 plus root 3 over 2 root 2. And then I could just simply write that as 1 plus root 3 over 2 root 2. Okay, now, or suppose somebody was more into rationalizing their denominators, okay? So they wrote 1/2 times root 2 over 2 plus root 3 over 2 times root 2 over 2. What's the denominator now? 4. So this is root 2 over 4 plus root 6 over 4, root 2 plus root 6 over 4. Both of these are equally acceptable. Okay? in your book, in the back of the book, the answers are rationalized. For me, it doesn't have to be rationalized. My eye is trained when I'm grading to know that these two are the same. Okay? All right. So both are the same. Okay. Now, what if you have something like this? 7 pi over 12. Oh my. How do we do that? Okay. So, first of all, I don't know about you, but I would rather have sine of a positive angle than sine of a negative angle, right? So now, if you have sine of negative theta, what is that the same as? Negative sine theta. So why don't we just do that first? Why don't we say this is the same as negative sine 7 pi over 12. Now what we're going to do is we're going to have to break down the 7 pi over 12 into two angles, which are special angles in the unit circle. So, it has to be a combination of like pi over 4, 2 pi over 3, one of those, okay? So, let me show you. Okay, so some people just look at it and they're like, it's this plus this. Okay, I was never one of those. So let's figure out how we can do this. My denominator is a 12, right? So why don't I write this as 2 fractions over a 12? Pi, right? Something pi over 12 plus something else pi over 12. Now, I have to come up with two numerators that when I put them with the 12, it will reduce to a special angle. Okay, so for example, if I do 5 and 2, that adds up to 7, right? But does 5 pi over 12 reduce to a special angle? No, so that's no good, right? So can I come up with another one?
4 and 3.
4 and 3? 4 pi over 12 plus 3 pi over 12, that'll work, right? Can it be 1 and 6? No, because 1 pi over 12 is an angle, right? So I do 4 and 3 because now those reduce. So now I have,
You could do 3 and 4.
yeah, you can do 3 and 4. Right. Once you, in the beginning you have a choice, and then once you do it, you're committed. So negative sine of 4 pi over 12 is pi over 3 plus pi over 4. Okay? So now, this is going to be negative. And now look, it's sine, cosine, cosine, sine, right? Sine, cosine, cosine, sine. Okay, so sine of the first, cosine of the second, plus cosine, sine. Okay, so, and then you'll see that basically what you're doing is each of them are getting a sine and each of them are getting a cosine. Okay, so this is equal to minus, by the way, does this problem look like something that was on the practice test or on the test, right? Like with sine of something times cosine of something. So this is why we learned it in section 4, in chapter 4. This is why I say in chapter 4, you've got to be quick. If you have to draw the unit circle every single time to do one of these, it's going to slow you down. Is it wrong mathematically? No, but it's going to slow you down. You have bigger fish to fry. Good news is it's still not late. If you're still having difficulty about that stuff, come see me. So, negative sine of pi over 3 is root 3 over 2. Cosine pi over 4 is what? 1 over root 2. Plus cosine pi over 3 is 1/2 times 1 over root 2. So this is negative root 3 plus 1 over 2 root 2. Okay, you can write it that way. You can also say negative root 3 minus 1 over 2 root 2. Or you could say negative 1 plus root 3 over 2 root 2. All of these are different ways of saying the same thing, and they are all acceptable. Okay?
And you want to wrap that.
Yes. Okay. Next. Find the exact value of, oh my gosh, this mess. Tangent of 78, I have no idea what it is. Tangent of 18, no idea. No idea. I don't think anybody does. But you kind of look at this for a minute and you're like, that's it, it's over. Like, that's it. My life is over. I have no idea what to do here. But not really, because when you sort of take a step back, look at the form. Look at what form this has. This has the form, I'm going to clear up some space here. This has the form tangent of some angle minus tangent of some other angle over 1 plus tangent, hey, of the first angle, tangent of the second angle. Have we seen that before?
Yes.
We've seen that before here. So this is a problem that's asking you to work backwards. I've given you this. Now what is all that equal to? Tangent of A minus B. So all of this is equal to tangent of alpha minus beta. So this is equal to tangent of alpha minus beta, which means it's tangent of, what's the first angle? 78. Minus, what's the second angle? 18. That's tangent of 60. Oh my God, we totally know what tangent of 60 is, huh? How much is tangent of 60? It's either root 3 or 1 over root 3. Root 3. And that's all. Okay, so this is one where we're being asked to work backwards. Okay. Now, look at this one. This is another one where we have to work backwards. Look at what I have here. I have cosine of an angle, cosine of another angle, plus sine of the first, sine of the second, right? So if I just ignore the angles for a minute, what do I have? Cosine, cosine, sine, sine. That's the second part of the song, right? Cosine, cosine, sine, sine, right? So that is a cosine. I have cosine alpha, cosine beta, sine alpha, sine beta. So I look, cosine, cosine, sine, sine, right? Where is it? Cosine, cosine, sine, sine. Is it this one or this one? They're right because there is a plus here. So that must be cosine alpha minus beta. And this is cosine 7 pi over 8 minus 5 pi over 24. Notice the parentheses. So by 3, this is 21 pi over 24 minus 5. How much? Over 24, which is cosine 2 pi over 3. Oh my God, that's like totally one of our favorite angles. Cosine of 2 pi over 3, top right, top left quadrant, right? Cosine of 2 pi over 3, negative 1/2. Okay. See how far we've come? It's beautiful. Okay. Oh my gosh, oh my gosh. Look at how beautiful this one is, guys. Okay. So In chapter 4, we did cosine of arcsine of root 3 over 2. That's where we stopped. Now it's cosine of this mess plus something else. Holy moly. Okay, so what now? What? Okay, so look back. I have cosine of something plus cosine of something else. Okay? So first and foremost, it's cosine of alpha plus beta. So first, I have to expand this, and it's going to be cosine, cosine, sine, sine. So cosine of the first, this one, I'll color code. Cosine of the second minus or plus? Minus. Now it's sine of the first and then sine of the second. Okay, so if you just look at the purple, I have cosine, cosine, sine, sine. Then if you look at the colors, I have angle A, angle B, angle A, angle B. So A, B, A, B. Okay, now, some of these we can just eliminate right off the bat. What's one that we could just eliminate and simplify like that? Huh? That one? What is arcsine root 3 over 2? For what angle is sine root 3 over 2? Pi over 3. Right? So that's pi over 3. What's cosine of pi over 3? 1/2. So arcsine of root 3 over 2 is 1/2. Is pi over 3. So, okay. And so that's cosine of pi over 3 is that. Okay, now, how about this one? What's that? That's just x because it's cosine of arc cosine. So that's just x minus, oh, wait a minute. This should be an arc sine. Okay, I got 1/2 because arcsine of root 3 over 2 is pi over 3. The angle for which cosine is sine is root 3 over 2 is pi over 3. Cosine of that is 1/2 times x minus, okay, this should have just canceled, so it's just root 3 over 2. Okay, so the only one that we actually have to do some work for is this one. And this is like, what do? We draw a triangle. I have an angle, the cosine of which is x. X over 1. What's that missing side?
I know.
So if we call that a, x squared plus a squared equals 1. 1 minus x squared. Okay? So the sine of that angle is root 1 minus x squared over 1. So now, I have here x over 2 minus root 3 times 1 minus x squared in a root over 2. So look at how we simplify that. That's a denominator of 2. And I have x minus all in the root. 3 times 1 minus x squared. For this one, I have sine of arctangent minus arc cosine of a half. So why don't we, from the beginning, say that arc cosine of a half is equal to what? What's the angle for which cosine is a half? Pi over 3. So now this is my alpha and that's my beta. So why don't we expand that? It's a sine, so it's going to be sine, cosine, cosine, sine, right? So sine of arc tangent of x cosine pi over 3 minus cosine of arctangent x times sine pi over 3. So I have sine, cosine, cosine, sine, and then I have A, B, A, B. Okay, so cosine of pi over 3 is 1/2. Sine of pi over 3, root 3 over 2. Now, it's these that I need to work at, right? So, back in chapter 4, when things were simple, just this one green part was a problem of its own. Now look, it's a quarter of another problem. All right, so look at how far we've come. Okay, what am I going to do here? What am I going to draw? A triangle. You could draw a rhombus, I guess, but that wouldn't help you. Okay, so there is this mystery angle theta, the tangent of which is x. Opposite over adjacent is x. So this is x squared plus 1 in the root.
Wait, isn't it 1 minus x squared?
It's 1 minus x squared if it's one of the legs. Okay, so for this first one, I need the sine. So it's opposite over hypotenuse. For the next one, I need a cosine. So it's adjacent over hypotenuse. Okay, let's write this function. I have x over the square root of x squared plus 1 times a half minus 1 over the square root of x squared plus 1 times root 3 over 2. Magically, my denominators are both 2 root x squared plus 1. In the numerator, I have x times 1 minus 1 times root 3. And guess what? I'm done. Okay, because you don't have to rationalize the denominator. The book may have, but we don't have to. It's fun rationalizing that denominator, but we're not going to.
How would 2 times the square root of x squared plus 1 minus 2 times the square root of x squared plus 1? How would that equal?
So it's like doing, like if you have 3 over 4, but if you have 3 over 4 plus 5 over 4, right, you just keep the denominator.
And then you do the subtraction and then
yeah. Okay, do you remember in chapter, yeah.
Wait, how did you get from cosine of x
5.1. Do you remember we learned about this identity? Right? What if somebody stopped you on the street and said, hey, can you like verify, like can you prove that to me? Can you show me that? Well, what would you do? You'd be like,
You would plug it in.
So here is what you would do starting tomorrow. You would say, oh my God, okay, why don't we take a look at this? Okay, I want to show or verify that cosine of negative theta is cosine of theta. How do you get, what's one way to write negative 4 using a 0? 0 minus 4, right? So, can I rewrite negative theta as 0 minus theta? Can I do that? Why not, right? Because if I ask you how old you are, you could say I'm 16, or you could say I'm 0 plus 16 years old. That's like totally the same thing, right? And so I can either say negative theta or 0 minus theta, whatever, it's the same. So now I can rewrite this as cosine of 0 minus, cosine of 0 minus theta. And so the word verify this trig identity, this concept comes from section 2, which we didn't do. And so that process of verifying something has, you know how in geometry proofs are in 2 columns and like you literally have a line down the middle? It's the same thing here, but we have an imaginary line down the middle. So it's very important that we try as much as possible to align the equal signs top to bottom. And so what we do is we're going to work on one side, left side, left side, left side, left side, and then all of a sudden we're going to get to a point where it equals the right side. So we're going to keep this aligned. Okay. When I write cosine of negative theta as cosine of 0 minus theta, what do I immediately convert that into? Cosine, Right, it's cosine of alpha minus beta. So now it's cosine, cosine, sine, sine.
Oh,
Yes. So we're going to start all the way up here. Cosine, cosine, 0 theta, plus sine, sine. Okay? It takes a while to know exactly where to start, so you end right at that equal sign and like everything is aligned. That's a special skill. Okay, now look at what I have here. I have cosine of 0. Hey, how much is cosine of 0? 1. It's a 1.
Wait, what?
Cosine of 0 is 1.
Why?
So here I have 1 times cosine of theta plus, hey, how much is sine of 0? 0 times sine of theta. And what's 0 times anything? 0. So what does this end up with? Cosine of theta equals cosine of theta. So do you see how we verified and we showed that cosine of negative theta is really just cosine of theta? Okay, so we use the sum and difference identity to show that. And guess what? You can do the same thing to verify the cofunction identities and any of the even and odd identities. Okay? Maybe a cofunction identity will show up on a test. You never know. Yeah. See? Okay. Oh, speaking of cofunction identities, here we go. Okay. Cofunction identity. Is this the cofunction identity or not? Cofunction identity is cosine of pi over 2 minus theta. But this one is cosine of theta minus pi over 2. It's the negative of it. But since it's cosine, does that matter? It doesn't, because we just proved that it stays the same. Okay. So, I have cosine of blah minus blah, right? Alpha and beta. So it's cosine. So the plus sign is going to be here. Cosine, cosine, plus sine, sine. Right? Cosine, cosine, sine, sine. There's always going to be something that will go away. What's cosine of pi over 2? 0. So that whole thing will be 0, right? 0 times whatever. What's sine of pi over 2? 1. So this is 0 plus sine of theta times 1, which means this is sine of theta equal to sine of theta. Right? So we did a negative, we did a odd even identity. We did a cofunction identity. Now we've done 2 of them. So chances of this showing up on an assessment are now twice as high as it was before we did the second one. Okay? Yeah. That's a good question. Try it and see. Let me know how it works. Not now, though, after I'm done teaching. Okay. Oh my gosh. Now look. We have an equation. Remember 5.3? We solved equations? Okay. Look at this one. Oh my. Look at this one. What do you have? Cosine A plus B. Hey, that's like a sum and difference identity. But there's more. Minus sine A plus B. Hey, that's like a second sum and difference identity. Twice the chance to use an identity in one problem. So let's do it. This is like 3 mini problems in one. When you have something overwhelming like this, rather than just, give up, we divide and conquer. So you divide and conquer. So first, I only focus on this. I don't even see the rest. Cosine of alpha plus beta. That's cosine, cosine, sine, sine. So cosine, cosine minus sine, sine. Okay. Now there is a minus. And then I have sine alpha minus beta. Yeah? So that's going to be sine, cosine, cosine, sine. Okay. Because we're elegant math students and there is a negative in front, we put a bracket. And then it's sine, cosine minus cosine, sine equal to 0. Huh? Because it's minus all of this blue thing. So it's minus all of that blue thing. So there has to be minus. Now I'm going to distribute that negative. And it's going to be cosine x, cosine pi. You can simplify before you do that. I'm just taking an extra step. Minus sine x, cosine pi, plus cosine x, sine pi. This is my favorite part because things either combine or they cancel or you get zeros. Okay. Yes.
If it was like at the very beginning, it's cosine of x plus pi. If it was cosine of x minus pi, would that matter?
Yes, this would be a plus. Here.
Oh, okay.
Yeah. Okay, so now, what's cosine of pi? -1. What's sine of pi? 0. Cosine of pi is -1. Sine of pi is 0. So what I have now is cosine x times -1 minus 0 minus sine x times -1 plus 0 equals 0. Okay, so basically I have negative cosine x minus plus sine x equals 0. Huh? What? What? You can... Do they?
No, because it's a negative. Oh, wait.
Why is it minus 0 minus sign?
Because this one, it was 0 times, like this term becomes 0. So like sine of pi is 0. Right? Yeah. So it's this, cosine times -1, minus, this is 0, minus -1 times sine plus 0. Yeah. Okay, so right, exactly. So okay, so if you were to square this, you would get, okay, so there is a couple things here. Let's do, if you were to square this, the way it looks, you'll get cosine squared plus sine squared, right? Which is 1. And then you'll get minus 2 sine x cosine x, okay? Now, I want to show you something else that we could do. If I just bring cosine x to the other side, now I have sine x equals cosine x. And so now the question is, find all of those points where cosine x and sine x are the same, right? So, okay, so when you have a pi over 3, let's say, sine is 1/2, root 3 over 2, the other one is 1/2, right? Pi over 6, same. Either sine and cosine, they're either 1/2 or root 3 over 2. But for the pi over 4s, you have root 2 over 2, root 2 over 2. Now, take a look here. Here, sine of the pi over 4, cosine is 1 over root 2, sine is 1 over root 2. Here, cosine is negative, sine is positive. Here, they're both negative. And here, one is positive, one is negative. So, the quadrants in which both of them are the same are the first and the fourth. The third. So we could say x is pi over 4 and 5 pi over 4. Okay? Yeah. Plus or minus pi n, yeah. Okay. All right. So when you solve one of these, where you have to do, sum and difference, blah, 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 sometimes you'll get like 2 of the same thing, right? And so sometimes they'll add, sometimes they'll get this one. The reason why I did this one is we haven't seen one like this before. But sometimes you'll get something like 2 sine pi sine x, right? In which case, that's a much simpler problem. Okay. So take a look at this. It says expand the formula for the difference quotient for that one, for f of x equals cosine x. Okay. The way you do this is this. Oh, by the way, this should say g of x. I missed that one. Okay, that's g of x. So look at what, okay, so you're given an f of x, yes.
The comma above, is that a comma or not?
Comma, in the red, it's a comma. So you have an f of x, this is what you're given, and you want this f of x plus h, blah, 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 blah. So now, let's write f of x here for a minute. Okay? Now, if I were to ask you what's f of 0, what would you say? It's cosine of 0, right? Right, it would be 1. Now, if I were to ask you what's f of a, you would say, oh, that's cosine of a, right? Now, how about, so f of x, we know what it is. How about if I ask you for this, f of x plus h? Now that is cosine of x plus h. Okay? So if f of a is cosine of a, then f of x plus h is cosine of x plus h. Right? So let's write our g of x for a minute. G of x is f of x plus h minus f of x all over h. So g of x is f of x plus h, I just said here, is cosine x plus h, minus what's f of x? That's just cosine x all over h. But we can expand cosine of x plus h. Right? It's cosine a plus b. So that is cosine, cosine, sine, sine. Are you guys seeing a theme here? Right? Cosine, cosine, sine, sine. So it's cosine, cosine, minus sine, sine, minus cosine x, all over h. Yeah, so before I take, so this one, this is how we leave it. The reason why we do this, this is sort of like it's half of an actual thing. And the actual thing, the complete of this, we see it once in chapter 12. It's actually like directly from calculus. But we see it again in chapter 12, right? But right now it's important for you guys to get that concept of f of x plus h minus f of x. Okay, so this is it. I think the whole sine, cosine, cosine, sine, right? That's easy to remember. And then one thing that really, really helps is if you have sine, the plus and minus is maintained, right? Plus, plus. If you have cosine, the plus and minus get switched. Okay? The way I used to remember it when I was in high school is, we didn't know the song then, right? This is a new thing. The way I remember it is cosine, like, it's cosine and cosine, like, that stays the same, so you have to switch the sign. Whereas here, like, you switch up the trig functions, sine and cosine, you have to keep the plus the same. I mean, it's all like, you know, it's all made up stuff, but that's pretty much all you have to remember. Okay, so let me talk. Okay, so that's the end of section